This is a right triangle, and we're given some angles inside the right triangle, which means we're going to be using SOHCAHTOA. Pythagorean's theorem is great when you're just talking about the sides, but when you're talking about the angles, you need SOHCAHTOA. And I want to remind you what SOHCAHTOA stands for. SOHCAHTOA. Okay. This means the sine of an angle, theta, is equal to the opposite over the hypotenuse. Okay, that's where the SOH comes from. The cosine of an angle, theta, is equal to the adjacent over the hypotenuse. And the tangent of an angle, theta, equals the opposite over the adjacent. So look over those three trig ratios. Which one seems appropriate for this problem? Here's the angle, A. Here's something I have, that side right there. And here's what I want. I want this side right here. Well, your first job is to identify where is the hypotenuse of this triangle. You should know that the hypotenuse is always the long side of a right triangle. Okay, so that's the hypotenuse. And adjacent means next to. So this guy right here is the adjacent side. So adjacent and hypotenuse tell me I'm going to want to use the cosine function. So let's go ahead and set up what the cosine of 30 degrees is. Okay, cosine of 30 degrees equals adjacent over hypotenuse. Now, if you remember what the cosine of 30 degrees is, that would be awfully helpful. You really should know that. It's one of the special angles. These things need to be memorized. Okay, the cosine of 30 degrees is radical 3 over 2. And that is equal to, well, adjacent is 6. And the thing I want, I'm just going to call that x, okay? The thing I want is x. That's the hypotenuse. So all we need to do now is just rearrange this. It's a formula. It has one variable. We can solve this by multiplying both sides by things to get rid of those variables. First thing I'm going to do is multiply both sides by x, right? That'll cross out these x's. And then I'm going to multiply both sides by 2. That'll cross out these 2's. So now, look at what you get. You have radical 3 times x equals 2 times 6, which is 12. Simplify that by dividing each side by radical 3, and we get 12 divided by radical 3. Great, that's what the missing side is that we want. Oh no, it's not here. So there's something else going on, which is that you also need to know how to rationalize a fraction. Instead of dividing by radical 3, I could try to move the radical up on top of the fraction. And the way we do this is by multiplying by a crazy 1. Right? Take a look at this radical 3 over radical 3 thing. That's equal to 1. I'm not changing the value of x when I multiply by this. All I'm doing is I'm changing the way it looks. So this becomes 12 radical 3 on top divided by 3 on bottom. Right? Square root 3 times square root 3 just equals 3. And 12 divided by 3 is 4. So I've got 4 radical 3 as my answer. That's the same thing as 12 divided by radical 3. If you'd like, you can put it into your calculator, type them both in, you'll get the same number.